Hello everybody, this is Alex Merced, Senior Tech Evangelist here at Dremio. What I'm going to do in this video is walk you through the exercise in this blog from JSON, CSV, and Parquet to dashboards with Apache Iceberg and Dremio. So the idea behind this exercise will to take files that are sitting in object storage, ingest them into Iceberg tables, and then build a Apache Superset dashboard. Okay, I won't go through sort of all the sort of explanation and concept text that's in the blog. I will have a link to this blog and other blogs in the video description, so do check that out. But yeah, let's do that. So first step, what you want to do is actually get the repository that it's going to have all the assets you need for this particular this exercise. So what you do is you're going to right click on this link right here, repo was set up for exercise. I'm going to open that in a new. And what you would do is you would create a fork. So you would click over here, create a fork of this repository, so that way you have your own copy that you can then clone down. I own this repo, so I am going to just clone down the original version. So I'm just going to go here. You would do this on sort of your fork. So after you click fork, that would take you to your copy. And then I would just click copy URL to clipboard. And then I would go into VS Code. So I'm using Visual Studio Code. And I would just open up a terminal. This could be done in just a standalone command line, but I'm going to do it within the integrated terminal here in Dremio. So, I mean, in VS Code. And again, here in VS Code, again, I have this opened up to an empty folder for doing this exercise. So that way it's nice and clean. And I'm going to do git clone to clone down that repository. So this is assuming you have git installed, which I'm assuming you do if you have Visual Studio installed. If not, you should download these things and install them before going further. Okay, but I'm going to basically hit enter there. Okay, it's going to clone down the project, so it's making a physical copy here on my computer of all those assets, which are all going to be right here in this folder. So you see here, Dremio file ingestion practice. Okay, I'm going to wait for it to finish. And done. Okay, so now we'll see we have all these files in here. And let's walk through that. What I'm going to do is I'm going to reopen my VS Code, so that way it's open directly from that folder we just cloned down. So you see this is folder Dremio file ingestion. I'm going to click File, Open Folder, and I'm going to go into here, Dremio file ingestion practice. So that way I have the repo directly opened. Okay, so let's explore what we have in this repo. So this README here kind of gives you some explanations of some of the stuff that's in here. But essentially, this all revolves around using Docker. So if you don't have Docker installed, this will be another thing you want to install. Go to docker.com. None of these things are hard to install on any operating system. But basically what we're going to do is we're going to create a fake sort of environment on our laptop. So essentially what's going to happen is we're going to have a bunch of containers. And if you're not familiar with like containers and images, basically in Docker's world, there's images, which are sort of like blueprints for mini virtual computers. They're not the same thing as a virtual machine, but we don't need to get into those nuances. So basically, these images are blueprints for these little mini virtual computers. And with Docker Compose, I can say, hey, I want you to create this collection of these virtual imaginary computers on my computer, okay, in an imaginary network. So essentially, it's almost like there's like a computer lab running right off of my laptop, and they're being based off these images. So I'm saying, hey, create one computer based on this image called Nessie, and that's going to be for our catalog for cataloging our tables on our data lakehouse. Okay, then we're going to have a virtual computer that's Minio, okay, and this is going to essentially be where we store our data. This is our object storage for storing our data, also referred to as our data lake. Okay, then we're going to have this other virtual computer or container that's really going to do one purpose. It's just there to set up Minio so that way you don't have to set it up later. So this is going to create all the different buckets you need in Minio, copy over the data that we have. So right here we have this folder called sample data. That's going to have a bunch of data in there for us to work with. Essentially what this is doing is going to copy over that sample data folder into Minio. So that way it's just already there. So you don't have to worry about that. Okay, so that's all this particular one's doing. And then we're going to have Dremio, which is going to be for running Dremio. Okay, so that we have Dremio running. And then we're going to have Superset, so that way we can do BI dashboards. Okay, so essentially what I'd want to do is get this all started up. Okay, and to do that, it's pretty straightforward. Okay, I can just click here in terminal, so I'm going to open up a terminal again. And I could open up all of these containers by just literally simply doing docker compose up. And what this does is that whenever I run docker compose up, it's going to look for a docker compose.yaml file in the same folder that I ran the command. This is the folder that I'm currently in. Okay, same folder as this. So it's going to find that file and then use all the directions that I put in this file that's already pre-done for you to create the environment that you want. Okay, so basically all this stuff is already kind of set up for you. You just do docker compose up, and now you're going to have this environment set up for you. Okay, so I will do that. I'm just going to think if there's any reason why I wouldn't just do all of them right now. Now, here's the thing. If I do that, it's going to end up taking over this terminal, and there's going to be just a bunch of constant output coming up. If I want to avoid that, I can do -D. This runs it in detached mode. So this means it'll run all the containers, but it'll run them in the background, so that way I can still use the terminal. Okay, so I'm going to do that. Okay, now it'll take a moment. Okay, as it starts up, basically, in this case, like 5 little mini virtual computers on my machine. Which, again, you may or may not be able to do depending on the amount of memory your computer has. Generally, I recommend for these exercises that I do like this, where there's a lot of containers, to generally have around 6 megs of memory available for Docker, which you can change in the Docker settings. Okay, although this one should work even with less memory. But that's all going to get all started up. So it's going to take a moment. So what I'm going to do is I am going to pause the recording while this downloads all the, because right now what it's downloading these images from Docker Hub. Docker Hub is where all these images get saved online for everyone to use. It's going to download them and then start them up. So it's going to take some time. Okay, so this is finished getting all set up. So basically all these containers are now all turned on. Okay, so now let's just double check that everything is kind of working the way that I expect it to. So first thing I'm going to want to check is whether Minio1 started up, and then that second container actually created all those buckets that I expected and put the sample data in there. So I can just check that by going to localhost 9000 or 9001. Either one's going to be fine. And that's going to take me to the Minio admin. The admin and password should be admin and password. So for the admin account. And if I go in here, and I don't see any buckets. Okay, so that tells me the second Minio setup did not start up, which supposedly started. So I will examine. Okay. So I just have to start up that one container again. So if you just want to restart a particular container in your Docker Compose setup, the command is this right here. So you see, notice I said Docker Compose up, but instead of saying, Docker Compose up by itself, I typed in the name of the specific service that I want to start. So you can see at the beginning of each service, there's a name for each service, and I can refer to that directly. So I can do Docker Compose up and then just restart that particular one. So I just restarted it, and based on the output, it looks like it did exactly what I wanted to do. Okay, and wrapped up. So let me refresh this page. Yep, and then there's my data. Okay, perfect. Okay, so just so you know, that's why we do double checks. Okay, so we double checked to make sure that everything was the way we expected, and when it wasn't, we addressed it. That's always the way you want to do things. Okay, step by step. Okay, so we have all our data here, and you can see we have 3 buckets: data lakehouse, sample data, warehouse. Okay, we're generally going to be using warehouse as our data lakehouse warehouse, meaning where we store our data for our Iceberg tables. Okay, so that's generally, we're never going to really go directly into this. This is going to be behind our Iceberg catalog, which is Nessie. Okay, and you'll see what I mean in a moment when we get to Dremio. And then we're going to have sample data, which is going to be, well, our sample data. And if I look in here, again, all that data we saw in our repository that we can now have access to. Okay, and again, if you fork the repo, you could add additional data if you really wanted to, if you wanted to have, additional data in there. Okay, so that's all well and good. So we've established that we have the data in there and the buckets are created. So now I'm going to head over to not dremio.com, but to localhost 9047. That's where Dremio will be living, our local copy of Dremio. So I'm going to head over there and set up my user account. Okay, so just sit there and be like Alex Merced. set up a username and email, set up a password. Actually, let me think of a different password. I'll just say password 2024. Password 2024. Just because we'll need that password later, so I want to make sure I expose a non-sensitive password. Okay, so basically uppercase password 2024 will be my password. I'm going to hit next. Okay, cool. So basically I'm now on the Dremio dashboard. So whenever you're starting with a fresh sort of install of Dremio, really the first thing you're going to want to do is connect all your different data sources. This is one of the beauties of Dremio. Okay, so I can just simply click right over here, or I can click over here where it says add source. Either one is fine. And this shows me a list of possible sources I can connect. Okay. In this video, we only really care about two. Okay, we're going to want to, because we want to interact with our lakehouse, meaning we want to interact with our data lake as if it were a database. And for that to happen, we need a catalog. The catalog basically gives us sort of a different interface. We're not looking at a sea of files. Instead, we're looking at a catalog of tables. Okay, in the same way that if you were to log into Postgres or into Snowflake, all you see is your tables. You don't see the individual files being stored somewhere that make up those tables. You just see tables. Okay, so when you use an Iceberg catalog like Nessie, you could also technically use Glue or Hive. You're going to basically be interacting with your data as a sea of tables with a sort of layer in between that kind of hides the underlying stored data. So I'm going to choose a Nessie catalog because Nessie is one of the things we created when we started up Docker. Okay, you can take a look at the Docker compose. You'll see there's a Nessie service in there. We're going to create a source called Nessie, and basically this should be the URL. Okay, so it's 19120 is the port, API/v2. Again, it should be Nessie because again, the way the networking works in Docker is that basically whatever the name of the service is, and you can always reinforce that using this container name property, is the name on the network. So the reason I'm able to refer to it as Nessie or MinIO is because I named it that way. Okay, so again, unless you changed my file, that should be the case. Okay, and we're gonna have no authentication. I'm just using a plain vanilla Nessie without configuring any kind of authentication or backing store. It's just in-memory storing evaluation version of Nessie. So that's going to connect to the catalog. The thing is that the catalog only tells you that the tables exist. The tables are actually stored in your data storage. So secondarily, I need to tell Dremio where the actual data is stored. So I need to point it to MinIO or MinIO to do that. Okay, in this case, we're going to store it in the warehouse bucket. So we just put warehouse as our root path. You can see by default, the settings are set up for like AWS S3. But here's the cool thing. MinIO is an S3 compliant object store. So I can just put in my MinIO credentials, which in this case would just be my admin password. And then all we need to do is set up a few properties to tell Dremio that, hey, we're not using S3, we're using something that's compatible with S3. So I'm going to uncheck this box here, the encrypt connection. The reason being is that this is running off our laptop. We didn't set up SSL certificates for all these different containers. That would be beyond sort of the scope of this exercise. But I'm going to click and add a few properties. So first one is going to be fs.s3a.style.access. What this does, it tells the Dremio to use path style access. So that means typically when it's using S3, it'll use a subdomain to refer to different buckets. So it'll be like warehouse.s3.com or lakehouse.s3.com. But MinIO uses a path, meaning it'll be like minio.com/warehouse/lakehouse. So the idea is that the way you know which bucket you're interacting with is in the URL. Now again, you never actually see that happening. Dremio kind of handles all that for you, but just so you understand why this property matters. Because if you don't turn this on, when Dremio makes requests to MinIO, it's going to use the wrong URL to make those requests. Okay, next we're going to put the endpoint. We're going to tell where MinIO is. Okay, and again, everything is following the name that it is in the Docker compose file. So in this case, the name is just MinIO, and it's going to be on port 9000. Okay, and the last thing is we need to turn on this dremio.s3.compat value. This tells Dremio to operate in compatibility mode, meaning, hey, you're not using S3, you're using an S3 compatible alternative. Okay, and once I have those settings set up, that's it. I'm going to have this catalog available. Just takes a second for it to establish the connection. Okay, but then you just wait for it to kind of establish that connection to the source. It's taking a moment. I might have made a mistake somewhere. Nope, it worked. Okay, cool. So there you see our connection to the Nessie catalog. Wonderful. So that's working great. But we want to access all that sample data so we can work with it. So that's going to require us to connect to the actual storage. So again, this is our catalog. So again, this is going to allow us to interact with our MinIO storage as if it were a database, while connecting directly to MinIO using an S3 connection will allow us to interact with our MinIO storage as if it were a storage or a traditional data lake of files. So it just depends on sort of like what type of connection you're establishing. This is why we have multiple buckets created. Our warehouse bucket is going to be for storing our tables, and our sample data bucket is for storing our sample data. So let me actually go back to the blog. I want to make sure that I set this up the way that the blog wants me to set this up, which is right here. So it wants us to call this source sample data. Okay, otherwise everything else is pretty much the same. So sample data. Okay, again, admin password. Okay, we don't want it to be encrypted. So that's all well and good. Okay, and then again, that tells us how to access the specific, the credentials for that storage. But again, we're not actually accessing S3. Okay, even though it says S3 source, we're accessing a compatible storage layer in MinIO. So we want to enable compatibility mode. So instead of having a set of that dremio.s3.compat, here we just have a checkbox. I wanted to point specifically to that sample data bucket, okay, because that's going to be where our sample data is. So that's going to be our root path. And then I'm going to click here to add property, and then we just have to add those properties you saw before, which is fs.s3a.path.style.access, which is going to be true. Again, so that way it uses that URL path style way of making requests, and the endpoint, which again will be MinIO 9000. And then that's it. We should be able to now access. Let me just double check. Yep, that should be good. I'm going to hit save. And now we should have our S3 source. And essentially, this is how it works with Dremio. You just connect a source, and then now you're going to have access to that data, and you can work with that data right here from Dremio as if it were, you know, all one system. And that's the beauty of sort of the convenience of Dremio. So there I can see all that data that I have in that sample bucket, and I can already query it as is. Okay, I could already head over to, let's say, 90s TV shows.csv. Actually, let's do Pokedex.json. Yeah, I'll just do the 90s TV show one. So I can go over here and say, hey, I want to take this, I want to query this CSV file, and so it'll just give me some settings to make sure that it parses that CSV file, right? So I can take a look at what the results are here. So hey, I want to make sure I get the column name, so I'll check that box off. Perfect. That looks the way I want it. Okay, and now I can already start running queries right there just directly on the CSV file. So at this point, I don't really have to do anything. I can just work directly with my CSV and JSON and Parquet files and do all sorts of querying with Dremio. Okay, the issue comes in when when those CSV files get bigger and bigger and bigger and bigger, those Parquet files get bigger and bigger and bigger. That's probably not going to be the ideal format to do querying in. Dremio can still query them pretty fast and has some fun tricks up its sleeve to make that work. But ideally, at that point, you're going to want to probably move to Parquet files. And eventually, your data sets aren't going to fit in one Parquet file. So there are going to be multiple Parquet files, in which case you're going to want to move to Apache Iceberg, because Apache Iceberg allows you to track sort of multiple Parquet files as one table, allowing you to kind of have those large scalable data sets. So what we're going to do here is we're going to take all this data that we have and move it into to Iceberg files, okay, tracked in our Nessie catalog. So now that we have our setup, okay, we're going to basically go step by step. So first thing we need to do is we need to create the Iceberg table that's going to receive the data. Okay, so here we're going to create a few tables. I'm just going to copy this code over. Okay, head back to Dremio. And right here, so basically here you can explore the data. Okay, spaces are for you to like create your own little folders to save views of your data on. That's generally where a lot of the collaboration in Dremio kind of occurs. You can click over here if you want to upload your own file, create new folders. Here's a wiki. Every object in Dremio has a wiki page, so you can put in documentation and explanation of what's going on that. So you have that. This page right here, this is the jobs page where you can see queries that were run and find details about those queries. So if you're the admin, you'd have access to this. And then here's the SQL runner where I can just, it's like an in-browser SQL IDE and provides a really nice experience. So I'm just gonna paste this SQL in there, okay? And it says it doesn't like it, but I'm pretty sure it should be okay. If not, I'll just get rid of all those spaces. Okay, but essentially what we're doing is we're creating 3 tables. The first table is going to be for our CSV data set. And then the second one's going to be for our JSON data set, because we're going to see 3 versions of this. And then one for our Parquet data set, which has the particular data set. And each of these has all the columns that we expect to have in the resulting data set with the right data type. And you'll see why this is going to matter in a moment, but I'm creating these empty tables that don't have any data yet. Okay, and just for safe measure, what I'm going to do is I'm going to add if not exist to each of these. Just in case I have to run this twice, just because I see those little red squiggly lines there, kind of warning me that there might be a problem with that third statement. So I just want to be preemptive about that. Okay, more than likely it's just like white space issue. Okay. Yeah, syntactically I see nothing of concern. Okay, so I'm going to hit run, and this is going to run each of these queries. So as you can see, like, it actually puts the results for each query in its own tab. So I can actually see the details as each query runs one by one. Okay, so it's creating the first table. Okay, and I got a lot of stuff running on my computer. So this is running purely off just my laptop's compute. Okay, that's taking a second. I think it's because I'm also building some Docker containers in the background, so I'm pushing my memory a little bit. Okay, so these ran, and again, the first 2 tables, as we expected, were completely created just fine. The third table, we saw that there was an error, so it looks like it's complaining about the particular character, so it's probably just the particular space character there. So what I'm going to do is I'm just going to get rid of the space for now, and just kind of do a little bit of that. Okay. Cool. I wonder if I can do multiple cursors. Oh, I can do multiple cursors. How neat is that? I'm holding down Alt, just like VS Code. I can do multiple cursors and make this a lot easier for myself. Haha. Yay for quality of life features. Oh. That's... Okay. Then I want to make sure there's only one cursor now, so I'll just click that right over here. And get rid of that last space. And then we'll run this again. The first 2 will run successfully because they already exist. And I have that if not exist clause in there. Okay, so just give it a second to, so yep, those 2 tables already exist. And now it's doing the third table. And now the third table is created. So now we have we have 3 empty tables. These are 3 empty Iceberg tables. And if I were to go back to min.io, I can actually see that they already exist. So actually I'm going to go to localhost 9000. And if I head over to warehouse, that's where we're warehousing all our tables, I'll see like, hey, look, there's the 3 tables. Each of them have their own folder. Each of them have their own metadata that tracks the details of the table, but there's just no data files currently in the table. Okay. So what I want to do is I want to move over my CSV data into that table. I want to move my JSON data into that table. And I could use what's called a CTAS, create table as statement, and I would be able to skip this whole step of creating a table and just create a new table as the original data set. Okay, and just to show you what I mean, I'll do that with like the Pokemon data set. So let's actually just show you how that would look like. So I'm gonna head over back to sample data. I'm gonna query that JSON, this Pokemon data. I'm gonna hit JSON, save. Yeah, that's fine. Okay, and now if I run, I can see the Pokemon data. Here's JSON, and if I really wanted to, I could go here and I could unpack this JSON data in there. Like Dremio has functions to help you sort of like pull up all these fields individually, but I just really want to just demonstrate something. So now if I did this, so I'm going to create a new tab. I can create a new tab here in Dremio, so that way I can keep the stuff from previous tabs there. I'm going to say create table as, create table nessie.pokemon. as select star from sample data dot Pokedex. Okay. Although there might be an issue with that sort of JSON conversion, but we'll see. Okay, I'm going to run create table Pokedex.json. And what it's going to do is going to create a new table. Awesome. Okay, so we have a new table. It's created. And if I go to my Nessie catalog, okay, I can see that there's this Pokemon table there. And if I run it, developments, okay, yeah, 151. Okay, yeah, it's just because there's so many different things in that array. Too many things in the Iceberg array. Probably just to kind of illustrate a better example, because I would have to unpack that JSON to really make that a thing. Let's do it again. Create table Nessie.tv shows as select star from sample data dot 90s TV shows.csv. So once again, I'm going to create a new table. So what it does is just it's going to run this query and take the results of this query and make a new table. Okay. And run that again. There we go. Okay. And now if I go back over here, I go into my Nessie catalog, I can see there's the TV shows table. And if I run the query on it, there's the data. But if you notice that every field, because CSV is a text-based data file, every column is a text string field. Okay. For example, number of seasons should probably be a number field. I could manually fix this. Like now that I've made the table, I can go in here and, convert data type and all this stuff, but that's really tedious. This is going to be the beauty of this other method I'm going to show you. Since I've already pre-made the tables with the right data types, so I know which columns are supposed to be numbers and which columns are not supposed to be numbers. When I copy over the CSV data, it's going to be able to convert it on the fly. And this is using a thing called copy into. Okay, as you can see here, we're going to use copy into. And you can see sort of all three examples for all three tables. So again, we'll go back to our SQL runner. Okay, and again, doesn't like the way that the particular character that's used for spaces in these. Okay, so we can always just clean that up. Okay. Okay, but if you see these copy into statements, what I'm doing is I'm saying, hey, copy into this table the data from this file. So I'm saying, hey, look at my sample data folder or data set that I've connected, and then there's a folder called CSV dataset. So I want you to copy the whole folder. The whole folder is a folder of CSV files. So that's what the file format CSV is, and I want you to take all the CSV files in that folder and copy them into this table. So that's another nice thing about this method is I can take a whole folder of CSV and a whole folder of JSON and then copy them over. And I can even do it with Parquet. So we have these three other sort of data sets in there. Okay, so now if I run this, and another thing to point out is that right now I'm doing this in a branch called ingest. So actually first I need to create that branch. Okay, so let's actually add, oops, because I think in the blog I do that, but I did that in a separate step. So let me just copy that over. And essentially what happens is that when we're using Nessie, you get that Git-like functionality. It's a very unique feature to a Nessie catalog. That's not a any catalog kind of thing. So in Nessie, I can do this extra stuff where I can create a branch to isolate the work I'm doing. So I'm going to create this branch called ingest, and then I'm going to make all the changes to the tables in there. Okay, so if I hit run, it's going to create. So basically now it's going to do all the ingestion. So it's going to write all those Parquet files. So basically what it's doing is going to read all the data in the CSV folder, write Parquet files, and then make those part of the Iceberg table. And then it does the same thing for JSON, and it does the same thing for the Parquet files. Okay, the end result is that now that data is inside my Iceberg inside those Iceberg tables, which again, at a small scale like this, not going to make a huge difference. But when you start getting to like, gigabytes or terabytes or petabytes of data as one single table, this can make a huge difference, having it set up as an Iceberg table. Okay, so That's all set and good. Okay, now just to kind of illustrate what happened here, let's actually query the data on different branches. So you can see that, hey, look, the changes that I just made aren't in what's the sort of the default branch called main. And the reason why that matters is that typically if I'm setting up Dremio, all my users, they're going to generally query data off the main branch. So if I'm the engineer, I can then create these branches, change the data, work with the data without necessarily exposing it right away to the end user. Okay, so you can see here, we're going to, for each table, we're going to query it on the main branch and the ingest branch. The main branches always exist by default. All the other branches you would create, like we just did a moment ago. Okay, oops. What does it not like about that? So app branch ingest. Is it a space thing? Because otherwise it looks the same as everything else. I think it's just confused. Yep. Okay, so see, it's running all the queries. And you can see, like the first one, if I take a look at the main branch, the table is still empty. But if I look at the ingest branch, I see all the data is now in there. Wonderful. Okay. Neat. And you can see ID is a number field. So it is taking the data types. And if I go to the JSON data set, again, on the main branch, no data. On the ingest branch, there's data. And you see all the fields have the appropriate data types. See, these are numbers, these are strings. And then if I go to the Parquet data set, I can see here, no data on the main branch. And here's all the data on the branch. Okay, this was like a larger data set, so this is why it's giving me this warning, because the UI just gives you, if there's more than like 100,000 records, it's just going to show you the first 100,000 visually on the screen. And it's just telling you that, hey, this is not every record, just so you know. This is just a sample of the record, so that way you can kind of inspect it. Okay. Cool. So I'm going to get rid of that warning there. But we've established that those changes haven't been made. Now, do I have to now go back and merge each individual change? No, I don't, because they're all in the same branch. All I have to do is merge that branch back into main. So I'll create another tab, just so that way I have all the other tabs for reference. I can just run this merge statement. And now all those changes will become published. Done. Okay, so now if I rerun this again querying both branches, by merging in the ingest branch back into the main branch, I've now published those changes. So now anyone who's running just normal everyday queries can now see that data. So again, this is beneficial from the engineer who may want to hide the data or may want to create like experimentation that they don't want to expose to everybody else. So they just create a branch just to play with the data and do some weird stuff with the data that they don't want other people seeing because they don't want to screw up other people's queries. But now if I go here, see now the data is available on main. So you see all of these are going to generally show the right results. Okay, so yeah, simple as that. So we basically ingested the data. So now it's time to build the BI dashboard. So we need to connect. So what we're going to do is we're going to start up. We already have the container running for Apache Superset from when we did Docker compose up earlier. But you need to initialize the container so that way, or run the Superset init command, so that way Superset kind of initializes itself. So we're going to run this command right here. And so we're going to head back over to VS Code. Paste this command. And this basically means docker exec. So I want to execute a command against a particular container that I have running. Okay, and the one that I want to run it against is Superset. So that's the container that I have that's called Superset. And then the command that I want to run is Superset init. Okay, so that's what that's saying. Okay, and again, how do I know that that container's named Superset? Is because, again, I named all these things in my Docker compose file. This takes a minute to run, so I'm going to let that run, and then we'll be able to access Superset in the browser. Cool. So now that is complete. Okay, and we're going to find Superset on port 8088. Okay, so that's where we're going to go. We're going to head over to localhost. And again, if you're unfamiliar with the term localhost just means your computer. And your computer technically is always the IP address 127.0.0.1. So technically, I could also just go to, was it 8088? That would work as well. Localhost 8088, or the IP address, it's all the same thing. Okay, localhost just makes it easier so you don't have to remember the number. Okay, and then here I have to put in the username and password, which I'm going to refer to the blog. Okay, and it's going to be admin and admin. Okay, so I log in with admin and admin, and now I'm inside Apache Superset. Okay, and essentially the workflow here is, and it's just like any other BI tool, essentially what you do is you're going to connect data sets. So we're going to connect where our data is, and then from that data we're going to build charts. Okay, and then once you build charts, you can then populate those charts onto a dashboard, which you can then share with other users. Okay, so this is again an open source BI tool, but works pretty much like most other BI tools you've probably worked with. So again, that's generally the workflow: connect data, build charts, put charts on dashboards. So we'll go through those first two pieces. But basically, first thing I want to do is go here, the data, and I want to connect a database. Okay, and what you want to do is click over here where it says supported databases, and you're going to scroll all the way to the bottom to other. Okay, and then basically what you do is we're going to head back to the blog here just to copy the path we want. Okay, so we will copy this URL right here, put that right into here, and essentially what we want to do is put the username. So in my case, it was Alex Merced was my username, and my password was password 2024, and then that should be it. So if I take a look at this, the rest of the URL should have what I need. Okay, and then just to make sure that it's working, and again, use encryption equals false because I'm running this locally. Again, you would change that if you were using a production deployment that does have an SSL certificate. Here I hit test connection, and I'm just going to make sure that this little screen over here pops up saying, hey, look, connection looks good, and I can hit connect, and huzzah, that's it. And now I'm connected to Dremio. Okay, and now I can start working with all those data sets, and it doesn't matter which. So basically, if I have all my different data sources connected to Dremio, I now have access to all my different data sources. Okay, that's another really nice thing. It makes it where it's a lot easier to manage all these connections across all these tools because they can just connect to Dremio instead of having to connect every tool to every data source to build what you need. So it just creates all these really nice. So now I can go back and start choosing the data sets I want to work with. So I can click here, add a data set. And then basically here I can choose a database, which just means really which of my connections. So Dremio. And then schema is going to be basically which source essentially. So you can see here, here's my Nessie source, sample data. So I'm going to say, hey, Nessie. And then here I can see like all the different tables that are under Nessie. Okay, in this case, let's say flights. Okay, and see there's all the data in flights. And I can say, hey, I want that data set. And now I can go, I click here, it'll create the data set. Let's try it again. Oh. It isn't cooperating right now. So let's try a different one. CSV. Okay, that worked. Okay, and then it's going to take you to here. And so you see here, I can see which data set I want to use. So if I wanted to choose a different data set, there's all these like sample data sets that it comes with. Okay, that you can work with, but there's that data set. I can choose what kind of chart I want to make. So we'll say this kind of chart. And then from here, I can begin constructing my chart. So I can type in the name of the chart. I can start copying in sort of what fields I want to use and building the chart. Okay, this will be similar to any BI tool. And then once I have those charts made, I can just head over to dashboards and start building dashboards. But that's it. That's basically, in the last 40 minutes, we've gone from taking data files in our data lake, turning them into Iceberg tables, and then connecting them to a BI tool. And it didn't take that long. Again, 40 minutes, end to end. Not so bad. So hopefully you guys enjoy these tools and play more with them. Feel free to take that sample data folder and restart this exercise and add data that you would want to work with to play with in there. You got some flexibility here, but otherwise, have some fun. I'll put the links to everything in the video description. Have a great day and enjoy.